Hi guys, today we are going to talk about algebra. I'm going to discuss fundamentals of algebra. It is very important for you to understand the fundamentals of algebra because they are the building block of algebra. Once you understand the fundamentals, you will find that you are going to run smoothly. There will be no obstacle in front of you. Okay, so I will start with the first topic, which is number one. Number one, it is real numbers. Real numbers. I'm just trying to write real numbers. Real numbers. Wow, my handwriting. This technology is not yet efficient. I hope you guys are going to become computer scientists and improve systems. So, under real numbers, we are going to discuss various numbers. There are many numbers. There are many types of numbers that were invented. I'm sure you remember when you started schooling, I think you do this in grade 1, where you do your whole numbers, you start counting, they teach you to count. You start from 0 and count up to 100 every day. Still remember those times. So today I am discussing the first one. It's going to be natural number. A natural number. What is a natural number? A natural number, do you want to give it a try? A natural number is all numbers starting from 1 up to infinity. So, natural numbers, it's all numbers starting from 1 up to infinity. Natural numbers. It's numbers starting from 1. They start from 1, 2, 3, up to infinity. This sign stands for infinity. Let me write it in a clear way. So infinity is represented by a sign similar to 8, but horizontally. That's it. There you go. Okay. So natural numbers, they start from 1 up to infinity. We know that. Secondly, we are having integers. So integers are numbers starting from negative infinity to positive infinity, passing through 0, of course. So you have your 0, 1, 2, up to infinity. On the left hand side, you have your negative 1, -2 up to infinity. Okay, so this is what you have up to infinity. Let me clean my board below here. So this is what you have. Thirdly, the third one, we are talking about rational numbers. I find that most of the students, they have a problem with rational numbers, and they tend to confuse rational numbers with irrational numbers. Seemingly, the explanation between the two numbers are not really easy to grab. So you must pay attention. I'm going to give you a clear distinction. So rational numbers are numbers that can be expressed as a ratio of two numbers. So any number that you can express as a ratio of two numbers, for instance, 1/2, 3/2, even 4, because any number that is a standalone, we know that it is that number over 1. So we're having these rational numbers. Rational. The pen is not writing well. Don't know what's happening today. Maybe it will get better by time. Rational. Yes, rational. So rational numbers are numbers that can be expressed as a ratio. So when we say they can be expressed as a ratio, I want you to put this in your mind. R representing a ratio, M over N. So M could be any number, and N could be any number. But N must never be 0. Because if N is 0, let me put this condition here. N must never be 0. Because if N can be equal to 0, when you divide any number which is represented by M, you are going to get an answer that is undefined. That is what you get, undefined. It's meaningless, and we don't want that. Then we come to an irrational number. An irrational number. Here you must pay attention. So a rational number, we said, it can be represented by R is equal to M over N. That is how you can represent it, a rational number. How about a rational number? A rational number cannot be expressed as a ratio of the two numbers. For instance, R is equals to M over N. For irrational numbers, you cannot do that. And irrational number cannot be written as a simple fraction. You see, rational numbers can be written as simple fractions. For instance, 1/2, 3/2, or 3/4, whatever. That is a simple fraction. You can write it. But on the irrational number, you cannot do that. And then the other thing is that these irrational numbers, when they are written in a decimal format, they never stop. They just go on and on. I mean, there are so many numbers which are like that. I mean, you can take your calculator now. Let us try root 8. Do your root 8 there, you'll see. I'm getting 2,84,84,27,125. You know, it goes on and on and on. That is how you see an irrational number. So an irrational number, irrational. Irrational. I'm going to try and write steady. Irrational. Oh, when I write slow, it becomes clearer. So irrational numbers cannot be expressed as simple fractions. That's point number one. Point number two, these numbers, when written in their decimal format, they just go on and on and on without any repetition. That is important to note. Is important. So these numbers, they cannot be expressed as fractions, right? So you can imagine, for instance, take your calculator and do root 8, you'll see. And another number which I know you know very well, a number pi. A number pi. This number goes on, and we know how we find a pi. It comes from the circle, a pi. So you take the perimeter of the circle and you divide it by the diameter. You get a pi. That number never stops, never stops. Pi. That's it. Okay. So we have discussed a natural number. A natural number is a number that starts from 1 to infinity. Integers are all numbers starting from negatives, passing through 0, to positive numbers up to infinity. So you can imagine integers as numbers that run from negative infinity to positive infinity. And then we come to rational numbers. These are numbers that can be represented or that can be written as simple fractions. Simple fractions. And we use a formula which is R is equals to M over N. It makes things simple for us. So any number can be represented like this. But you must make sure that the value of N is not 0. The value of N must never be 0. Because once it's 0, it's going to be undefined. Number 4, we spoke about an irrational number. I want you to get this thing straight and clear. Irrational numbers can never be represented or written as simple fractions. They are just not like that. They refuse to follow that rule. That is why they created this type to accommodate specifically what you see in the irrational numbers. They cannot be represented as a simple fraction, and when they are written in their decimal format, it's numbers that just go on and on and on and on. They never stop. I think you understand that. We're going to move on and discuss something very important. Properties of real numbers. Properties of real numbers are important because they actually tell us what to do in algebra. Algebra, you find it everywhere. When you're doing your functions, your graphs, you find it. When you do your geometry, you find algebra. When you do your trigonometry, you'll find algebra. You'll find algebra everywhere. So it's important that you have the fundamentals. I'm going to show you all the fundamentals. These are the keys of algebra. To unlock your potential, you need to understand the properties of real numbers. And we're still going to do other properties like properties of fractions. I'm going to give you a full lesson, a simplified version of algebra. That is what you're going to get from me. That is a promise. Now, I want to change the slide and talk about properties of real numbers. Let me see if my pen writes well. Okay. Properties. Oh, now it's writing well. Properties of real numbers. Oh, I think it's coming right. My prayers are getting answered. So, properties of real numbers, we're going to talk about just three things. Just three. Pay attention. The first one, I'm going to talk about distributive property. I like it. You know, this thing of distributive. Distributive. Distributive What is it that we're talking about in distributive property? We're talking about distributing something into many other things. A distribution. I have a bag of oranges. I give it to different children, one by one. Each child gets one orange. I am distributing the oranges. So that is what I am going to do here. I'll make you an example, but in a general form. My examples are going to be in a general form. Most of them, about 90%. There is a reason why I'm doing that. I will not be doing problems, I don't want to dwell too much on examples because you end up forgetting what you've been learning. That is a problem. I want you to grasp these laws. I want you to grasp the rules and to grasp the properties. This is what I want to dominate your mind because these are tools. So a distributive property, how does it happen? You are multiplying a number into a sum, into a sum of two numbers. It could be three numbers, it could be many numbers that are encapsulated inside or within the brackets. So how is it going to look? This is how it would look. The representation. You need to understand the representation first. So we have A into B plus C. Now when we do the distribution, I'm going to represent it in a red line. You multiply A and B. You come again and multiply A and letter C, which is equal to A multiplied by B. You get AB. You bring back this sign. If this was a subtraction sign, you'd bring it back. So in this case, it's a plus sign. And then A times C, it is AC. This is how it works. There is a section that we are going to do in algebraic expressions where we'll be talking about the difference of two squares and and so on. This thing is going to come back, you'll see. Distributive property plays a major role in algebra. Number 2. We are talking about the associative property. Associative property. Let me write it. Associative property. In an associative property, we talk about adding 3 numbers or more, or multiplying numbers. And we say, in this case, the order does not really matter. The order does not matter at all. How are you going to see this property? Maybe you have A plus E plus F. It is the same as having E plus F plus A. You are going to get the same number, the same answer. On the left hand side and the right hand side, you're going to get the same thing. Now, I want you to be careful. I said here we're talking about 2 things. It is addition and multiplication. We're not talking about subtraction. We're not talking about division. 2 things. Addition and multiplication. So let us look at multiplication. You may have A multiplying E and G. So you're going to have A, E, G. This is what you're going to get. But it's also similar to taking E and multiplying A and G. The order does not matter. You can take G outside the bracket and put E and A inside the brackets. You are still going to get the same answer. I want you guys there at home to try these properties. Just put any numbers. You assign a number to A, a number to E, a number to G. Multiply them and reorder it and multiply again and see if you're not going to get the same answer. You will. That is what we mean by associative property. Number 3. We are talking about a commutative property. A commutative property. Commutative property. In the commutative property, we're talking about adding two numbers, 2, or multiplying two numbers. And we're saying in this case, the order does not matter. How are you going to see this structure? It is like this. You may have A. Oh, we've been using A's too much. Let me use X now. Okay. So you can have X plus Y, and it is equals to Y plus X. It's the same thing. And you can have X multiplied by 1, Y. This dot means multiplication. And Y multiplied by X. You will get the same answer. You'll get the same answer. So guys, I want us to look at the work that we've done so far. I don't want to confuse you with too many things. There are a lot of things that we're still going to do in geometry, in algebra. There's a lot. And all those things, they must be in your head. They must be in your head. So you must understand these things very well. Can we do a recap? Okay. Right, here's my screen. We said we were learning about real numbers. Under real numbers, we spoke about 4 types. One was a natural number. We said a natural number starts from 1 to infinity. That must be in your head. You must know it off by heart. Number 2, we have integers. Integers is a combination of negative and positive numbers. They start from negative, they run to positive, passing through 0. So you can imagine that is numbers that go to infinite on the negative side and they go to infinite on the positive side. Then we come to the last 2. A rational number. A number that can be expressed as a ratio of 2 numbers. And here we are using a formula. R is equals to M over N. We have one special condition though, which you must always remember. This condition, N must never be equal to 0. Otherwise, R is undefined. Try. Do it on your calculator. You can put any number in place of M. You can put any number, then divide it by 0. You'll see your calculator is going to tell you it will return undefined. But if you put any number, it will give you that fraction. It will give you. The last one, an irrational number. We said there are two things, just two. The first one, irrational number can never be expressed as a ratio of two numbers. Never. Number two, irrational numbers, when written in their decimal form, they just go on and on without stopping, and without repetition. And I gave you an example. You must calculate the square root of 8 in your calculator. You'll see, you just get a number that fills up your screen. And if you do it on a computer, you'll just get a number that fills up your computer screen, So, real number properties are important. And we also recap the second one, the second slide, where we spoke about properties of real numbers. The properties of real numbers, there is 3 properties. The first, distributive property, whereby you have a number that multiplies a sum of 2 numbers or a difference of 2 numbers that are encapsulated in a bracket. And we multiply. We take the number that is outside the bracket and multiply the number that is inside the bracket, one by one inside the bracket. Number 2, we have an associative property. Here we are talking about the addition and the multiplication of 3 numbers. And we are saying the order does not matter at all. I have given you the examples there. This is what you must know. It is your work, it's your assignment to assign values to these variables and put whatever number you like. You'll see what's going to happen. Number 3 was a commutative property, where we talk about only 2 numbers and we talk about 2 conditions, 2 operations. It's the multiplication and the addition. And again, we stated that the order does not matter. I hope, guys, you understand this thing. I hope you'll be able to work with these properties because they are important. They are the fundamental building block of algebra. We're still going to do more. So please subscribe, share, and like this lecture. You can send it to your friends so that we can also unlock their potential to do algebra. Okay, guys, I'm taking a break now. When we come back, because we're going to have a series of lectures, we're going to start with the properties of negatives and we'll do the properties of fractions. Thank you.